So irrational numbers have got non-terminating decimals. They fall in this category. When you divide a number which is, let's say a number which is irrational, will always give you these non-terminating decimals. The decimals will keep on going and they can't be expressed in a ratio form like this. So when you are able to express a certain number in a ratio, let's say a whole number like 5, this can be expressed as 5 over 1 or 5 to 1. This is a ratio. So this number is rational. That's where the term rational comes from. It's from the word ratio. When you are not able to express a certain number in a ratio form, it means that number is irrational. So e.g., the number which is irrational number, this. Try to compute this on your calculator. You'll find that it will give you 1 point something, 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 something. The decimals will keep on going. They won't end, which means they are non-terminating decimals. Unlike when you compute this number, the half on your calculator, you'll find that it will give you a 0.5, which means the decimals have got an end point. That's what it means when you say rational and irrational. So defining real numbers, you combine both numbers, irrational and rational numbers. Those are real numbers. And know that real numbers are represented by the capital letter R, like this. That's the symbol for real numbers. Let's proceed. When it comes to the natural numbers are represented by the capital letter N, like this. And these numbers are counting numbers starting from 1, 2, 3, going forward, starting from 1. When it comes to the whole numbers, they are represented by the capital letter W, like this. These are counting numbers starting from 0, 1, 2, 3, and so on and so on. Even numbers. So even numbers, these are numbers which have got the multiple of 2. The multiple of 2. So these numbers start from 2, 4, 6, and so on and so forth. So those are numbers which have got a multiple of 2. They are always divisible by 2 and they are multiplied by 2, like a multiple of 2, which means each and every number, a 2 must be added, or it should be multiplied by a factor of 2. That's the reason why I've put a 2 in front like that. It means these are numbers where 2 can go in without leaving a remainder. Then odd numbers. These are simply numbers where 2 cannot go in without leaving a remainder. So these numbers are represented by this formula, which means they start from 1, 3, 5, 7. These are odd numbers. Numbers which are not divisible by 2, which means a factor of 2 cannot go in. Those are called odd numbers. Those are odd numbers. So when we come to the integers, these are numbers starting from positive infinity to negative infinity, to positive infinity, meaning numbers on the real line or on the number line. This is 0. These are positive numbers. These are negative numbers. So all numbers on the number line, or all numbers from the negative infinity, this side, to positive infinity, these are called integers, and they are represented by the letter Z, capital Z, like this. That's the symbol for integers. The symbol for numbers is capital W, capital letter N for natural numbers, capital letter R for real numbers. Irrational numbers I've explained. I just have to put this now into consideration. Let me explain a little bit. Irrational numbers, I just told you that they have got non-terminating decimals, but put this in mind also, they have got non-repeating decimals. Non-repeating decimals. What do I mean when I say non-repeating decimals? This number, 0.12, when you see a bar on top of the decimals, just know that the 1, 2 is repeating itself. It's like this, 1, 2, 1, 2, 1, 2. So when you see a bar like this, just know that the numbers are repeating. These decimals are repeating. Repeating decimals, these numbers fall under rational. Then the non-repeating decimals, they fall under irrational. So make sure you put this into consideration. Then complex numbers, as at now, it's not necessary for you because these are imaginary numbers. They are like this. They have got a real part and the imaginary number, which is represented by the letter I. These numbers, they are like this. A root of negative 9, like this. These are called complex numbers. You'll get to learn them as we go forward. But as at now, I'll simply leave it here in terms of the numbers and the introduction. Yes. Let's proceed to rational numbers. Rational numbers, just like I indicated earlier on or explained, I said these have got non-terminating, or these have got terminating decimals. Sorry, they have got terminating decimals. Secondly, they have got repeating decimals. Repeating decimals. So, and thirdly, they can be expressed as a fraction, e.g. in form of a over b or p over q. If they can be expressed as a fraction, it means they can also be expressed as a ratio, e.g. this fraction can be expressed as a to b, and this fraction can be expressed as p to q. These are ratios. So that's where the term rational comes from the word ratio. When you are able to rationalize something, it means that number has got a ratio and it is rational. So this is how questions may be phrased. They can ask you to say, prove that 0.5 is rational. Prove that 0.5 is rational. How do you do it? When you see something like this, just do this. Try to put this number in form of a or b, which means try to put this in a fraction form. How do you do that? Do this. Let 0.5 be equal to x. 0.5 be equal to x. Then count the number of decimal places. So in this case, you've got one decimal. Then if you have one decimal multiplied by a factor of 10, 2 decimals, a factor of 100, 3 decimals, a factor of 1000, 4 decimals, a factor of 10,000. So just going like that, you should just be adding zeros as the number of decimals increases. So let's do this. Let's multiply both sides by a factor of 10 because you've got one decimal. So when you multiply 0.5 times 10 and you multiply x times 10, you're going to have a 5 like this, which is equal to 10x like this. 5, 10x like this. Then do this. Once you have got this, simply find the value of x. How do you find the value of x? Divide this both sides. Then x is equal to 5 over 10. 5 here is simply 1 into 10 is simply 2. So it means this number can be expressed as in form of a or b or as a ratio a to b. This is 1 to 2 in a ratio form. In a fraction, 1 over 2. So this number is rational. So when we say this, sorry, not repeating, oh yes, repeating decimals. So I've just said terminating decimals, you have found that 0.5 doesn't have continuing decimals. So you have proved the point number 1. Let us prove the repeating decimals to see whether a number which has got repeating decimals, whether it is rational or irrational. Let us prove that one. So prove that. Let me use a different marker. Prove that 0.12, the repeating bar, is rational, which means we have to express this same number as well into a fraction form or ratio form to prove whether it's rational or not. So how do you do that? Let's do it the same way we did to that one. We say let 0.12 with a repeating bar be equal to x. Then how many decimals do we have? We simply have 2 decimals, so we are going to multiply by a factor of 100 both sides. So 0.12. So when you see this, make sure you rewrite this like this. Yes, because they are repeating, you can rewrite it like this. You can keep on going. But in this case, I'll just write 2. 0.1212 by 100 is equal to x by 100. So make sure you mark this as your equation 1. Then this one, which you are going to obtain from this one, it should be equation 2. So here when you multiply, you're going to have 12.12, which is equal to 100x. This is equal to equation 2. So how do you do it now? Finally, subtract equation 1 from equation 2. So how do you do that? Just do this. Subtract the 2. You've got this. 0.12 is equal to x. Just subtract these, the like terms, and subtract this. Then you get the answer. So when you do that, you're going to, this part is 0, and this part is just 12. So 12 is equal to 99. Because 100 minus x is simply 99x. Then you find the value of x, divide both sides by 99. You're going to have x is equal to 12 by, over 99, sorry. So this is the answer. When you do this, it means you have proved that this number indeed is rational. So try to compute this on your calculator. You see that it will be giving you 1, 2 repeating decimals. The 1, 2 will keep on repeating. 1, 2, 1, 2, 1, 2, 1, 2, just like that. Let me show you. Let me use my calculator. I show you. Here's the calculator I'm going to use. Don't worry. That's my calculator. So let's say 12 divided by 99. As you can see, the 1, 2, 1, 2, 1, 2 is repeating itself. So when you do like this, it means you have shown that indeed this number is rational because you have expressed it in a fraction form like this, which means you can also express it in a ratio form. 12 to 99. This is a ratio form. So this is how you can prove the numbers, if indeed they are rational or not. So make sure you stick to this explanation. As you can see, repeating decimals fall under rational. And these are repeating decimals. No wonder I indicated a bar. So when you see this bar, just know that the number is rational. The 1, 2 is repeating itself, just like I've shown you on my calculator, like this. And in fraction form, it is 12 over 99. So this is how you can do it. Make sure you stick to this explanation. You let x be equal to this. Then multiply by a factor of 100 if the decimals, if you have 2 decimal places. Then when you multiply, you simply have 12.12 because the 1, 2, 1, 2 is repeating. So you're going to have 12.12 is equal to 100. Then subtract equation 1 from equation 2. You will simply have 12 is equal to 99x. Then find the value of x. You divide both sides by 99. You're going to have x is equal to 12 over 99. When you compute that on your calculator, 12 divided by 99, you will simply have 0.121212. The 1212 will be repeating. It means the number is rational. So like this, guys, I would like to give you, let me give one example before I go to irrational numbers. Remember that number I gave you, the number we are proving? See, it had decimals like this. Only the 2 decimal places we are repeating. Now in this case, I want us to prove this one. To prove this one, 0.125. Now the repeating bars are after this 1 decimal place. How can you do this? So when you do this, simply do this. Let x be equal to 0.125. These are repeating, so you can even extend them like this. So just know that how many decimal places don't have a repeating bar? So we have got this one. So kindly multiply by a factor of 10. So it will be 10x, and this will be 1.2525 like this. When you multiply both sides by 10, then how many decimals have got a repeating bar? The decimals which have got a repeating bar, these decimals are, okay, let's do this. This number is simply this. So how many decimal places now do we have? We simply have 1, 2, 3. So multiply by a factor of 1000. So you say you multiply equation 1, this equation. So when you multiply this by a factor of 1000, you're going to have 1000x is equal to 1000x is equal to 125.2525, like this. This is what you are going to have. My markers are fading. I'm running out of ink. 2525. So now regard this as equation 2. Then subtract equation 1 from 2. So, this is 3. This is equation 2. So subtract equation 1 from equation 2 from equation 3. This and this. So when you do that, you are going to have this. Let's subtract 10x from here. Then we subtract 1.2525 from this number. You see the numbers which you are going to get. So this side, when you subtract 1000 minus 10, you're going to have a 990. 990x is equal to, this will cancel because they are just the same. This will be 124. Then find the value of x, divide both sides by 990. Then your value of x will simply be 124 over 990. Like this. This is your answer. So let's try to prove whether this number will give us the 25 repeating decimals. So let's try. You see, here's my calculator. 124 divided by 990. As you can see, this is 0.125252525. It means the repeating numbers are just 25. As you can see, 25252525. This is repeating. The number which I've got repeating decimals, it's simply a rational number. As you can see, we can also express it in a fraction form. It can also be written in a ratio form, which means this number is rational, guys. I hope this is clear. We move on to the irrational numbers. Irrational numbers. Irrational numbers. What do we mean when we say irrational? We go back to the definitions I gave you. Said these are numbers which cannot be expressed as a ratio. As a ratio. Cannot be expressed as a ratio. You can't express them in this form. In this form. A over B or P over Q. At the same time, these numbers don't have repeating decimals. Repeating decimals, and they have got non-terminating decimals. It means the decimals just go on and go on. They can't end. They don't have an end point. They can't terminate. That's the reason why we say non-terminating decimals. Then they have got non-repeating decimals. Just like we were doing earlier on, we were proving rational numbers. Rational numbers have got repeating decimals. So let us try to see how questions might come. How they can phrase questions. They can phrase them like this. Prove that the root of 2 is irrational. This is a little bit tricky, so I would like you guys to pay attention on this one. Prove that the root of 2 is irrational. So how can you do that? Just equate this to this. Say let the root of 2 be equal to A or B. We see whether this number can be expressed in this form. We try to see whether this number can be expressed in this form. So let's work out this one. Second step, we square both sides so that we can eliminate this root. Squared. We're going to have 2 is equal to A squared over B squared. Like this. Over B squared. Then when you work out this one, you're going to have 2B squared is equal to A squared. Like this. Then Let's see whether this number can be, whether this number can be expressed in this form, or whether it is irrational or rational. Let's see. So how do you do that? Say b is even. Is even. How can we say that b is even? How do we know? Simply because it has a multiple of 2. Any number with a multiple of 2 is even. Remember, I showed you something like this. 2n, meaning this is even. It's an even number because it has a 2 in front. It is a multiple of 2, this b. So b is even, which means if it's even, we can replace where there is b, we put this 2n. Excuse me, or 2r if you want. So you can say 2n squared is equal to a squared, like this. If we work out this one, we're going to have 4n squared is equal to a squared, like this. Then this will be 8n squared is equal to a squared, like this. Then let's try to see now. Now that you have done this, if n is even, and so a is even, because if you can square a number, it means you can it has a multiple of 2. Let's say this n, for you to find the value of a, it means it has got a multiple of 2. Even n, if a squared is divisible by 8, for you to find the value of n, you do this. N squared is equal to a squared over 8. It means if this is even, the number which is dividing the a squared, it means even this number is even. So you can see this number cannot be expressed as a ratio or a fraction. Let's prove this. We've got this expression, 8n squared is equal to a squared. So I'll start proving. Let's say let the value of n be equal to 1. The value of n be equal to 1. Then we substitute where there is n, we put 1. We're going to have 8. You're going to have 8 is equal to a squared. To find the value of a, you're going to have a root of 8, right? So let us try to compute the root of 8 on our calculator. You will see that the root of this will just be going the value of this. It will have non-terminating decimals. Which proves that this number is surely irrational. Let me see whether I'm sorry, my calculator is not a scientific one. The one I'm using right now, I'm using a small phone like this. So on your own free time, like in your free time, kindly compute this. You'll see that it will give you non-terminating decimals. So this is how you can prove whether the number is simply irrational. Like this, just equate the number you are given to a fraction, a over b or p over q. Then try to work out. Just follow the same procedure. When you do this, then you should come to the conclusion. When you see that the value which is inside there is not a perfect square, kindly, when you say let n be equal to 1, then you put 1 there is where there is n. You work out this expression. In the root there, when you find the value of a, make sure you check whether this is a perfect square or not. If it's not a perfect square, it means the number is irrational. This is how you can prove these things. Alright, so with this, I'd like to say goodbye on irrational numbers and rational. Next time we are going to look at intervals.